Hey, Algebra, we're going to be working on section 9.4, which is graphing these quadratic or polynomial functions. Before we start, I have a story for you. I was playing baseball out in a field, and the ball got hit, and then the ball got hit in the air, and so I was playing center field, and the ball was coming down, and I kept wondering to myself why that baseball kept getting bigger, and then it hit me. Hopefully someone laughed at that. All right, so we're going to be working in quadratic functions. After simplifying radicals, which was, the square root of 50 and stuff like that, these are very real world, which makes me excited. And that baseball example is a perfect one. Okay, so if we're talking about, here's home plate, and the ball gets hit up in the air, and then here's me in center field, this label of a graph would be a quadratic function. Okay, same thing with like shooting a basketball or hitting a volleyball or firing a javelin in Call of Duty, just things like that. But there's a couple important terms here. This point right here is called the vertex, which is going to be the max or the minimum of a polynomial or a quadratic. Okay? Each of these places right here are called the zeros. Or if you notice, since this is the x-axis, zeros are the x-intercept. Okay? And that's the place where y is going to be equal to 0. Okay? Those are the two important things you have to know about graphing quadratics. As we get into these things, they're always written in the form y equals ax squared plus bx plus c. Okay, and the values a, b, and c are really important. So as I look up at this graph, the first thing I have to do is I look at the numbers. Well, this x is by itself, so we have to do and's method and put the 1 in there. Okay, and then we have to find the values of a, b, and c. A will always be with the x squared term. So the coefficient of the x squared term is 2. The b will always be with the x term. So here, it's because we did and's method, it's a -1. And then the 2 is the c term because it's always by itself. So our values of a, b, and c are 2, -1, and 2. Now here's a little different. Because it's always written in this ax squared plus bx plus c, we know that if there is no b term and there is no c term, they're both going to be 0. Okay? And we do and's method to fill in the 1 here, so we know our a term is -1. All right, so those are the a, b, and c terms. Very important. Okay, so I want you to pause this and try these on your own. Find the values of a, b, and c for each of these and see how it goes. So I'm hoping you try these on your own. For this top one, the value, this is and's method, so that's a 1. The b value is with the x term. That's not there, so that's a 0 because there is no something times x. And this will be the -3. Down here on the bottom, and's method again for the x here. So it's -3, 1, and -1. Okay, so let's move on. Graphing these terms. Now, the first thing you need to know is we need to find the values of a, b, and c in order to graph. And I'll show you why in just a bit. Okay? And's method, so the value a, b is -2, c is -3. Okay? Now, the vertex, and this is important, the vertex will always be located at x equals opposite b over 2a. The reason why we learned the a, b, and c values. So opposite of b over 2a means that our vertex is going to be located at +2 over 2 times 1, which is 2. 2 over 2 is 1. And the reason why we do that is we're going to make a table, we're going to make a table of x, y values. And the center of our table is always going to be the vertex. So this point here goes right in the middle of our table at 1. Okay, then we think of the number that's closest to the left, that's 0. And we think the number that's closest to the left of that one is -1. So 1 to the right will be 2, and here will be 3. So we've made our graph. This point here is the vertex. So we have to plug each of these values in and figure out what it is. So at -1 will be 1 times -1 squared minus 2 times -1 minus 3. Okay, this is for -1. So this is +1, so that's 1 times 1. This is going to be +2, and this is going to be -3. So it's 1 plus 2 minus 3 is 0. If we plug in the 0 value, that one's pretty easy because it's 1 times 0 minus 2 times 0 minus 3, so it'll be -3. And 1 is our vertex. Okay, so then 1 times 1 squared minus 2 times 1 minus 3 will be 1 minus 2 minus 3, which would be -4. If you're having trouble with these, you obviously can break them down a little bit more than I am, and that's totally fine. Now, if you would continue on, you end up getting -3 and 0. Noticing a really interesting pattern, but first we have to graph it. So it ends up here, 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 and here. If we graph it, we'd be like this. Couple things that are important. The A value determines how it opens. So positive A value means it opens up, like this one, like a U, and a negative A value means it opens down, like a rainbow. So ours, because our A value is positive, our graph opens up. But there's something else that's important here. If the vertex is along this line, okay, and I decided to graph a dotted line through the center, you notice that it's like a mirror image of each other. So because our vertex is here at 1, the two values to the right and the left of it have to be the same, as long as they're the same distance away. And then the two values on the other side will be the same distance. So even though there's 5 ordered pairs, you're only actually going to be finding 3. Now, if this vertex is a fraction, that'll change it a little bit, but as long as it's the same distance away. This line right here is called the axis of symmetry. Axis of symmetry. Okay, so a couple things we found. The vertex is opposite b over 2a. The axis of symmetry splits it in center through the vertex. And then, of course, we just graphed our point from there, knowing our a value means it opens up. Okay, a lot of information, I know, but we're just getting the basics. Now, I want to finish up here quick because we're at 8 minutes. I want you to try to graph this on your own and see how it goes. Alrighty, so I'm hoping you gave this one a try. First thing we had to do is find our values of a, b, and c. Our a value is 2, our b value is -4, and our c value is -1. Our vertex would then be opposite b over 2a, so that's +4 over 2 times a, which is 2. So our b is 4 over 4, our b is 1 again. So we make our table. Alrighty, so our b is 1. That means we go 2, 3, 0, -1. And I'll kind of buzz through this one. We'll know that this is -1, this is -1, 2 minus -3 here, and this will be 2, 6, so 5, and 5. Okay, that seems right actually. So our graph is here, here, here. Okay, so that looks right. Not a perfect graph, hard to draw on the computer. But what I want to point out is that if you opened up your calculator, and I want you to do this, that after you graph these, you can graph them on your calculator to see how they look and make sure you did it right, which is totally fine. Make sure you zoom standard. And look at that. Using our table will tell us if we did it right. And look at that, it looks perfect. Alrighty, so we're going to come back in tomorrow, have a work day. But for now, that's what we got. Okay, we'll see everyone tomorrow.